Hello and welcome to a video on how to do question 9 from Step 2 2019. So I quite like this question, to be honest. I think this one and question 10 I prefer compared to, say, the pure questions, which is really unusual. Like most students, I normally prefer the pure to the applied, but I think some of the pure questions in this paper are really very tricky, whereas a question like this, actually, it's much more, I would say, obvious what you've got to try and do. Okay, we're told that something's being projected, standard kind of projection. So naturally, with any projection question, you're really just dealing with SUVAT in two different directions. I think it's easier to see what's going on as well if you write everything as a vector in this question, rather than sort of like dealing with it like the horizontal and vertical components, just write it as the vector. It might make things slightly clearer what's going on. Now, the question asks us to find the condition on sine of alpha for which OP is increasing for the whole flight. So let's just write down what we're given. We're told we're told to show that OP is increasing for the whole flight. The distance OP, that is, so it's the length of OP, is increasing for the whole flight. Okay. Now, when I see something like that, I suppose the distance OP just means I'm immediately thinking I need to find the length of the vector. The word increasing, that word immediately makes me think of increasing functions. Increasing functions are functions where the gradient is always positive, i.e. greater than 0. And that's really the two principles that I'm going to use when attempting this question. That and the fact that it's clearly about SUVAT. Now, straight away, the way I started this, as we're told that the initial speed is u, then the velocity vector should be u cos alpha and u sine alpha. The acceleration vector is just 0 and minus g. We've got the time as well, which we can call t. And, well, OP is simply s here, the vector s. So it's going to be ut cos alpha for the x component. And if you're used to resolving horizontally and vertically, that is just a horizontal component, and it's constant velocity. And the vertical component is going to be ut sine alpha minus g over 2t squared. And that is the vector OP. Another name for that, I mean, I've called it S here just to relate it to SUVAT, but it is how you get from O to P. Think of it as the path of the projectile. That's what it actually is. Now, I care about the distance, so what I'm going to do, and I'm just going to write down OP squared because I don't fancy putting a square root on the other side, but OP squared is clearly going to be this one squared plus this one squared, and so that's going to give me u squared t squared cos squared alpha plus, and now I've got to square all of this in brackets, so I'm going to get u squared t squared sine squared alpha. Then I'm going to get minus, now think about this carefully, you're going to be doing that times that and that times that again, so you're going to get minus UG t cubed sine alpha. Do it in a grid if you're worried about that, but that's what you should get, and then plus g squared t to the 4 over 4. And that is the distance OP squared. Now, what are we going to do with that? Well, if it's increasing, I think the best way of doing this is to note that OP is increasing. Provided the square of OP is increasing. Now, the reason I'm saying this is just so I don't have to differentiate something with a big square root around it using chain rule. That would be a real pain in the bum, that really would. So I'm not going to do that. I'm just going to differentiate it with respect to t as it is. So I'll just finish off writing the word increasing there. Okay, and that's cool. Okay, so what I'm going to do now is I'm going to differentiate this function. I'm going to go dOP squared by dt. It's a bit of a sort of cumbersome way of expressing it, but that's what I'm going to do. Now remember, u, alpha, g, everything except t is a constant in that equation, so I'm just going to differentiate it, but remembering that t is my only variable really. I'm going to get tu squared t 2u squared t cos squared alpha. Oh, sorry, before I do that, I've just missed a very easy tidy up here. This is clearly u squared t squared, because cos squared alpha plus sine squared alpha is just 1. So when I differentiate that, I'm going to get 2u squared t minus 3ug t squared sine alpha plus g squared t cubed, and there we go. Okay, now what I can do is I want this to be greater than 0. Yeah, now I can immediately divide through by t. Now I'm allowed to do that, and I've got to be careful with inequalities. I must be careful with dividing by 0, but really we're showing this is just true for t is greater than 0. Yeah, t equals 0 is at the start of the experiment before it's even been projected, so I can safely divide through by t here without causing too many problems. I'm also going to rearrange it as well to write it as t squared g squared minus 3ug t sine alpha plus 2u squared t, and that is going to be bigger than 0. Now really I've just got a quadratic in t, and if I've just got a quadratic in t and I want to show it's bigger than 0, then I've just got to put it in completed square form. So let's complete the square on it, but first actually what I'm going to do is divide by g squared, just because I'm a wimp and I don't really want to do that until I've written it like this. I'm just happier completing the square on something like this. I've also divided through by, oh, that's a mistake there, sorry about that, plus 2u squared over g squared, and that's greater than 0. Okay, cool. And I've divided through by t going from here to here, and then I've divided through by g squared. I probably should have done that all in one go, really. Anyway, complete the square. T minus 3u sine alpha over 2g, all squared. And then I need to subtract 3u sine alpha over 2g, all squared. So I'm going to take away 9u squared sine squared alpha over 4g squared. Tidy up that bracket there. And then this I'm going to write as 8u squared over 4g squared, and that's greater than 0. Now, this will be greater than 0 provided these two terms on the right are greater than 0. Yeah, because this is squared, and so it's always positive. And so I can say hence 8u squared minus 9u squared sine squared alpha over 4g squared is greater than 0. Times by g squared, divide by u squared, you're going to get 8 minus 9 sine squared alpha is greater than 0. And that easily rearranges into sine alpha is less than 2 root 2 over 3. And you've done the first part. Now, that's the first part. In the second part, it wants us to say, demonstrate that it is at least decreasing for some values of t when sine alpha is greater than 2 root 2 over 3. Now, if sine alpha is greater than 2 root 2 over 3, it's pretty easy to reverse engineer everything there and point out that 8u squared minus 9u squared sine squared alpha over 4g squared, that is actually going to end up being less than 0 then. Yeah? And so all we've got to do now is find a value of t which definitely ensures that that is 0. And the obvious value to pick would be t equals 3u sine alpha over 2g. So when t equals 3u sine alpha over 2g, clearly this function is decreasing. Now I ought to point out as well that that is definitely before the object lands, yeah? Because it must be within the time of flight. Now, when does the object land? Well, if you go back up here to this bit, you can see straight away that the object lands when 0 equals ut sine alpha minus g over 2 t squared. And if you factorize that and rearrange it, you'll see that it lands when t equals 2u sine alpha over g. Now, remember, we had 3u sine alpha over 2g, which is essentially 1.5u sine alpha over g. This is 2u sine alpha over g, and so this is definitely before the end of the flight. This is definitely before it lands at t equals 2u sine alpha over g. And there we go. So we've proved it. We've proved it. So that's part one done. Now part two is a bit trickier. Part two, the way I did part two, turned out a bit more messy really, but really it's very similar ideas. You've got P and then you've got Q, and we're looking at the vector QP. Now OP's vector is the same as before. OQ's vector, well, that's really easy because that's just going to be minus VT and 0 because it's not actually slowing down or speeding up. It's just speed is distance. It's just a position, if you like, is speed times time. Yeah, I mean, it's dead straightforward, OQ's vector. It really is. And that allows me to find QP's vector because it's just going to be OP minus OQ. And so it's going to be UT cos alpha plus VT and UT sine alpha minus g over 2t squared, and that is the vector QP. Well, that's lovely, isn't it? Because really, I'm just going to use exactly the same approach. Exactly the same approach. I'm going to find the length of this vector. It's going to be uglier, the algebra, no doubt about that. I'm going to find the square again. I don't fancy square rooting because it's easier to just differentiate the square of the distance. That seems a lot easier to me. Now, you're going to get u squared t squared cos squared alpha plus 2ut squared v cos alpha plus v squared t squared. Now, that's okay because we now get u squared t squared sine squared alpha, and that's where we're going to get the ut squared from, here and here. I don't know if you see that. I'm always looking ahead. Oh, and then minus, and let's budge up a bit so I can fit this on the whole screen. So where's the little hand? Let's just move this over and give us plenty of space. It's going to be one of those lines where you just have lots of terms. Minus, same as before, minus, so minus ugt cubed sine alpha, and then plus g squared t to the 4 over 4. So very, very similar looking, but the only difference is you're going to have u squared t squared, that's from those two terms, the sine squared plus cos squared is 1, plus 2u. Now let's put all the t squareds together actually. Let's put all the t squareds together. So let me just go back a bit because let's just tidy it up straight away. We're going to have t squared u squared plus v squared. That's from the u squared t squared. Oh, I've actually written that down. That should be a v. Oh no. Sorry, I'm getting slightly put off because my phone is ringing. Somebody's having the nerve to ring me at this point. So where was that? Yeah. U squared plus v squared plus 2uv cos alpha, and then we've got minus ug t cubed sine alpha plus g squared t to the 4 over 4, and I think that is the whole equation, and that is the distance, the square of the distance of QP. Okay, so that's all good. Now we're going to do the same approach again. We're going to differentiate that with respect to t, and we're going to get 2t, and I can just leave this in brackets because it's just a horrible constant, but it is constant. And then this is going to be really similar to what we had before. And we want that to be bigger than 0. Once again, we can ignore the case where t is 0 because we can just, that's at the very, very start, and I'm interested in once the projectiles have been fired, so I'm just going to ignore that. And I'm going to end up with a quadratic again. G squared t squared, once I divide by t, minus 3eg t sine alpha, plus 2 u squared plus v squared plus 2uv cos alpha, like that. And I've divided by t there as well. It's greater than 0. Same approach again as well. Complete the square. Same approach again. Oh, have I dropped a squared there on the g? So I end up with, let's see, I'm going to end up with, if I complete the square on this, I'm going to divide by g again, t squared minus 3u t sine alpha over g plus 2u squared plus v squared plus 2uv cos alpha over g squared is greater than 0. I then completed the square, 3 ut sine alpha over 2g squared, and now I'm going to have this time, and I'll tidy it up straight away, minus u squared sine squared alpha over 4g squared plus 8 times u squared plus v squared plus 2uv cos alpha over 4g squared is bigger than 0. Okay, so we've now just got to use the principles of completed square form. Let's forget about the 4g squareds and the u squareds. They cancelled ever so nicely last time, didn't they? We basically need 8u squared plus v squared plus 2uv cos alpha to be bigger than 9u squared sine squared alpha. So all I've done there is I've looked only at the last term, yeah, and I've times the 0 by 4g squared, and then I've moved the term across. That's all I'm doing. A couple of steps in one go, just because I'm getting bored of writing down so much tedious algebra. It is a bit of a slog, this one, algebraically. Now, the trick here is really to just rewrite this v as, because it would be nice if we had it as a cos squared, this 8u squared cos squared, and then we can get rid of the sine squared or some of the sine squared as well. So what I'm going to do is I'm going to write it as 8u squared plus 8u squared cos squared alpha plus 8v squared plus 16uv cos alpha. Now I've added 8u squared cos squared alpha to this side, which seems a bit cheeky. So I've got to add 8u squared cos squared alpha to this side, but that would just give me I'll write it out for you. U squared sine squared alpha plus 8u squared sine squared alpha plus 8u squared cos squared alpha. And can you see why I've done that now? Because that's just going to turn into 8u squared, which cancels with the 8u squared over here. So remarkably, you get left with this 8u squared cos squared alpha plus 8v squared plus 16uv cos alpha, and that's bigger than u squared sine squared alpha. Now you might think, what have you achieved there? Well, I've been able now to write this as 8 times u cos alpha plus v, and that's the trick at the end. It's this is the difficult bit, there's no doubt about it. U cos alpha plus v all squared. Brilliant. Now I'm in a really solid position because it looks like the answer is going to work out now. Now I can safely square root as both sides are clearly positive, so I can make that 2 root 2 u cos alpha plus v is greater than u sine alpha, and then I've essentially got to the answer because that easily rearranges into 2 root 2 v is greater than u sine alpha minus 2 root 2 cos alpha. Okay, cool. Hope that makes sense. I'm just going to write at the end as required. Please let me know if any of that confuses you. Be surprised actually if it didn't. These are step questions after all. They're not easy. Well done. Thanks for listening.